Capacitive voltage transformer is mainly used for measurement of voltage and for protection purpose. It is also used for power line communication between different substations. In this video, we are going to have details of the parameters which are mentioned on a nameplate of a capacitive voltage transformer. So to get this detail, you need to watch the video. In most of the countries, capacitive voltage transformers are manufactured as per IEC 61869-5. This IEC also gives us the parameters which should be mentioned on a nameplate or a rating plate of a capacitive voltage transformer. We will see these parameters one by one. So the first is name of the manufacturer. This will show you the name of the manufacturer. Next is insulation level. Now here you can see there are two values mentioned. One is in RMS and other is in peak. So let's understand what are these values. The first value which is mentioned in kV RMS is called as power frequency withstand voltage. And the second one mentioned in kV peak is called as lightning impulse voltage. These are the highest system voltages used to check the insulation properties of the equipment. It can also be called as insulation levels if combined, which you can see on the nameplate. Power frequency withstand voltage can be caused by these reasons: phase to earth fault, load rejection, ferroresonance, and Ferranti effect. Lightning impulse voltage is generally caused due to lightning strokes. Voltage generated due to these reasons can cause insulation failure of CVT or any other equipment. And hence it is important to check the insulation properties of the equipment. And to do so, power frequency withstand and lightning impulse test is performed as per IEC and based on the values given by IEC. So on the nameplate you can see for 245 kV voltage level, the values defined are 460 kV RMS for power frequency and 1050 kV peak for lightning impulse. Next is standard. This will give information about the standard as per the equipment is manufactured. Next is capacitance. CVT is a device made up of capacitors. It is the combination of two series capacitance C1 and C2. And the equivalent capacitance of C1 and C2 is given on the nameplate, which is 4400 picofarad. Values mentioned in the bracket is allowed tolerance in the equivalent capacitance. Standard values of equivalent capacitance are 4400 picofarad, 6600 picofarad, and 8800 picofarad. Next is primary capacitance. As we know, CVT is the combination of two capacitance C1 and C2. C1 is called as primary capacitance whose value we can find on the nameplate. Similarly, C2 is called as secondary capacitance whose value is also mentioned on the nameplate. So if you calculate equivalent capacitance of these two capacitors, you'll get the value equal to 4432.8 picofarad, which is within the tolerance. But remember one thing, values of C1 and C2 can be different for different manufacturers based on their design, because the ultimate aim is to get the equivalent capacitance equal to 4400. So I can play with the values of C1 and C2. Next is highest system voltage. This is the highest system voltage for which CVT is designed. This is also called as a rated voltage. So here it is mentioned as 245 kV. Next is voltage factor. On the nameplate you can see it is mentioned as 1.2 continuous and 1.5 for 30 seconds. What does it indicate? Let's see that. First thing is the number mentioned here are in per unit system, that is 1.2 per unit and 1.5 per unit. Voltage factor indicate highest voltage CVT can carry for specific time. So it is mentioned as 1.2 continuous This indicates that the CVT can carry 120% of rated voltage continuously. 120% of 245 kV is 294 kV and the CVT can carry 294 kV voltage continuously. Similarly, it is also mentioned that CVT can carry 150% of rated voltage, that is 367.5 kV for 30 seconds. This feature is required when the system is undergoing over voltages or voltage swells. Next is rated frequency. This is the power frequency on which the power is generated, transmitted and distributed. In some countries it is 50 Hz and in some it is 60. Next is simultaneous burden. This indicates how much apparent power we can take at the same time from all the provided windings without affecting the accuracy of metering core, that is 0.2 class. Secondary windings of CVT is generally connected on a same core and hence burden connected on one winding may affect the accuracy of other winding. And hence it is specified that how much amount of total VA burden you can connect on all the three windings of CVT without affecting the accuracy of 0.2 class. On our nameplate it is mentioned as 100 VA, which means we can connect total 100 VA on all the windings put together and still get the accuracy of 0.2. Next is thermal burden. This indicates the total amount of apparent power we can take from CVT at the same time without increasing the temperature of CVT above the specified limit by IEC. On the nameplate it is mentioned as 300 VA, which indicate we can take up to 300 VA power without increasing the temperature of CVT. Next is total weight. This will give us the total weight of CVT in kilograms. Similarly, total weight of oil, this will give us the total amount of oil used in CVT in kilograms. Year of manufacturing, this will show the year in which the CVT is manufactured. Now here you can see there is a table given on the nameplate. Let's see the details of parameters given in this table. So the first thing is primary and secondary voltage. Primary voltage you can see mentioned as 220 kV by root 3. 220 kV is mentioned in volts here. Remember one thing, instrument transformer are single phase devices which are connected across phase and neutral in case of CVT and in series in case of current transformer. And that's why the voltage is divided by root 3. Similarly, the secondary voltage is given as 110 volt by root 3. The CVT has 3 different windings and hence you can see secondary voltage is mentioned 3 times, which indicates 3 different windings. As per IEC, 100 volt by root 3 or 110 volt by root 3 are the standard values of secondary voltages. Next is VA burden. Now, whatever circuit you are going to connect to the secondary winding of CVT, it is called as burden. This includes the equipment which we are going to connect to the secondary like a relay or meter, and also the wires we are going to use to connect this equipment to the secondary winding. So as per the nameplate, we can connect burden up to 50 VA on each winding. These are the standard values of secondary burdens as per IEC. Next is accuracy class. As we know, CVT can be used for measuring as well as protection purpose, and hence different windings are used for different purposes. There will be a separate winding provided for metering purpose and separate for protection purpose, as providing separate windings offers many advantages. So for winding used for metering purpose, there are some accuracy classes given by IEC which you can see on the screen. These numbers have specific meaning to it. So for example, accuracy class of 0.2 indicates voltage error equal to plus or minus 0.2%. Similarly, 0.5 class indicates voltage error equal to plus or minus 0.5%. Class 1 indicates error of 1% and class 3 indicates error of 3%. So the lesser is the voltage error, the more accurate CVT is. This was about the accuracy class of metering CVT. There are accuracy classes for protection CVT also, which is 3P and 6P. 3P class means even if we apply 2% of rated voltage to CVT, the voltage or ratio error should be within plus or minus 6%. Similarly, 6P class means even if we apply 2% of rated voltage to CVT, the voltage or ratio error should be within plus or minus 12%. So of course 3P class is more accurate and better than 6P class. So as you can see on the nameplate, out of 3, 2 windings are used for protection purpose with accuracy class of 3P and 1 winding is used for metering purpose with accuracy class of 0.2. Next is fuse rating. On the secondary winding, fuse are provided for protection purpose, which you can see here. F1, F2 and F3 indicate the different fuses used for 3 windings. And the rating of the fuse is 10 ampere. Instead of fuse, one can also use MCB. On the nameplate, you can also see the diagram of CVT is provided. These are our series capacitance C1 and C2. This is the IVT, that is intermediate voltage transformer. And here you can see 3 secondary windings, which is the output of CVT. If you would like to read all these parameters we just saw, you can read my article on that. You will get link for that down in the description. So I hope you have found this video helpful. If you like the video, you know what to do. That's all for this video, guys. I'll see you in my next one. But till then, keep watching, keep learning.